So number one, we're going to start with the low graph, and the time it took was 3.92. So using the velocity graph, we can figure out that this slope is supposed to be negative 9.8 because acceleration of gravity is negative 9.8. By the way, we're making the acceleration positive, or we're making the up direction positive. So as the rocket goes upwards, it's positive. Coming back down, it's negative. That's why gravity is negative 9.8 consistently, because gravity is always going down towards the Earth. So the slope of this is negative 9.8. Divide this time by 2 to get the peak of the graph, and then yeah. So this is the peak. That's why I made this point coordinate point the xy 1.96 and 0, because velocity is 0 at this time. 0, and then this is supposed to be an x because we don't know the initial velocity yet. All we know is that 0 minus x, 0 minus x over 1.96 minus 0 equals negative x over 1.96 equals negative 9.8. Slope is acceleration, yada yada yada. So I'll be able to do number 2, slope being velocity and acceleration. Now number 3, the question is, what is a change in velocity? The change in velocity is 0 because it changes from, well, this is supposed to be this is supposed to be technically negative, but regardless, the change in velocity went from 19.208 to negative 19.208, so the total change is about 0. Actually, no, it's not about, it is 0. Okay. How fast was the rocket traveling? The rocket was traveling at a speed of 19.208 meters per second. I got that because of the graph before, right here. Okay. So now the slope of this is 0, and negative 9.8, and then this initial final, or the 0 of the velocity, and this is the x. And using this equation, just don't look at this part right here, just focus on this. You can find out that the final was 19.208 by using this equation, multiplying both sides, taking, just canceling out the negative, and x equals that. And since the initial is this, the initial is that. And so number 4, that's the speed at when it was launched. Okay. And number 5, is the speed of the rocket different from? No, it's not different, because it's not different because the velocity has to be the same in order for this graph that we've drawn out to be the same. So this triangle area has to equal this triangle area because the distance is the same and then the time it takes is the same. So we can look at this graph, this position graph. The peak of this is at 1.96 right here, and the height is 18.82. So if we imagine this parabola, the distance is from this point to this point is the same, and just as this point to this point is the same. So that means if it takes the same time to go to the same distance, then the velocity has to be the same just before it hits the ground and just as it's launched. So that's why the velocity is essentially the same. So it's not different basically. And then what's the maximum height? The maximum height is 18.82. This is number 6. 1/2 times 1.96 times 19.208. Now we can go back to this. The area of just this part is it's basically the maximum height. So since we know x is 19.208, that's where I got this 19.208. 1.96, 1.96 divided by 2, because it's a triangle and it makes the maximum height of 18.82 meters. Number 7, was the acceleration different when the rocket? No, it's not different, because if you look at the acceleration, it's constantly negative 9.8. Why is that? Because gravity is constantly going towards the Earth. the acceleration doesn't change as an object goes closer and closer to space, I guess. In every point on the Earth, the acceleration is always the same. It's constantly negative 9.8. Number 8. What was the total distance that the rocket traveled, and how did I figure this out? Well, the total distance is 37.64 meters. And how did I figure that out? Well, because we have to take this first peak. Now we know that the distance the peak is 18.82. That means that its highest point is 18.82, meaning it doesn't go any farther than that. So if we were imagining, say, something a car on a track, if it goes 18.82 and doesn't go any farther than that, its distance between point A and point B is 18.2. But because it's up in the air and comes back down, it's just as imagining the car going in reverse, the same distance. So its total distance would be just 18.82 times 2, which is where I got that 37.84. Yeah, 37.64, sorry. But yeah, you just double it. Oh, what did I do? Well, technical difficulties. Okay. Number 9. What was the total displacement of the rocket? Well, displacement would be 0. Because displacement is not the same as distance traveled, it's change in the distance. So because its initial was 0 and its final was 0, the change is 0 minus 0, which is 0. It doesn't matter how far it's gone, it just matters the change. So like that race car going on a track, it went from point A to point B, but point B to point A. So in displacement wise, it's only gone from point A to point A. But distance wise, it's gone point A to B and B back to A. There's a difference. Yeah. And 10, are the answers different for the last two questions? Yes. Because as stated before, displacement is not the same as displacement is not the same as distance. Okay, so that's it for the low. And moving on to the high. The medium, sorry. The medium is a basic same thing as so much noise. Basically the same thing as the low, just the numbers are tweaked because the time is tweaked. So the time is 4.50. Now we can draw the graph, same thing as the low. Acceleration, again, just like the low, is always going to be negative 9.8. Because it's always negative 9.8, we can do this, slope. One moment. Okay. Again, change in velocity is 0, because final minus initial is the same thing. Actually, now that I think about it, since I made positive up and negative down, this velocity of final would actually be negative. So rather than it being 0, and again, going back to this applies to low and all the future graphs, the velocity is actually double the initial velocity, but just in the negative number, because if final velocity minus initial velocity, it's a negative final minus initial. So it's a negative minus a negative means another bigger negative, because it's the same, it's double the size. Yeah, just don't mind this is 0. And then number 4 is the final velocity, or just the initial velocity as it's launched. Using this equation, the slope, and then finding out what x is, you can find out that the initial velocity is 22.05. Is the speed different just before? No, it's the exact same. The speed is the same, not the velocity. I guess what I'm trying to say is that the absolute value is the same, because again, same distance, same time, areas are going to be the same, nothing changes, so it's the same. 6. What is the peak? Again, the area of this is the peak. because this is half, and the peak is only half of the total system. So 1/2 times 2.35, because that's half of 4.50, times the velocity gives you 24.806 meters. Number 7, was the acceleration different? No, it was not. Gravity, as always, is constant. Number 8, what was the total distance traveled? The total distance traveled was 24.806 times 2, because again, peak is 24, that means up is 24, down is 24. So, that multiplied by 2 is 49.6125. My work is shown here, times 2. Number 9, the total change, the displacement is 0. How did I figure this out? Because it goes up the same distance and down the same distance, so the change is nothing. 10 is the answer is different. Yes, it's going to be this for all of it because they're all parabolas, but yes, displacement is the change in distance, not the total distance. And up and down, as long as it goes the same amount, it's 0. If it goes up 50 but down 49, the total change is actually 1, so the displacement is 1. But because it goes up 4.806 and down 24.806, the displacement is 0. Moving on to the high. The high times for 5.09, graph, constant. Let's go on to this. Okay, we know that this should be double if my assumption is right. Rather than 0, it's just twice the velocity, which we found out is this because of this equation. Using these points, 0, 2.545, and 0, and x, and then, constant acceleration, meters per second squared times meter per second, you get meters, no, you get, I'm sorry, you have, that's not relevant, you just want to find slope because, that's final velocity, which is, right there. 5, is the speed different? No, again, it's not different because same distance, same time, same acceleration, so it's all the same. 6, I got 31.237 meters because area of this triangle time is 1/2 because it's a triangle times 2.545 because that's the time it took, so it's the base. The height is what we found to be 24.92541. So multiply that all together and you get this number right here. Number 7, acceleration is not different, gravity is always the same. 8, the total distance is just this multiplied by 2, parabola. Number 9, total displacement 0 because up, down, same, no change, or change but in the same amount. So essentially, in displacement wise, it didn't really go anywhere. My answer is different. Yes, 0, 63. Again, displacement not the same as distance. Super. Okay, so the total time was 6.34. Half of that is 3.17. Acceleration, blah blah blah. This should be doubled. Velocity is just this equation, x over 3.19 times, 17 times negative 9.8, cancel blah blah blah, you get this. No, it's not. It didn't change because, I didn't draw this, but imagine just a parabola. Same distance, same time, same acceleration, same initial velocity, same final velocity. Number 6, 1/2, 3.17 times 31.0667 should give you 49.239. 7, was the acceleration different? No, because gravity is the same. Just take this, multiply by 2 to get this because the parabola is up, down. 9, no, the displacement is 0 because change, not distance. Up, down, same distance, no change. Or change, blah, blah, yeah. Yes, number 10, yes, they're different because displacement and distance are not the same. Alright, woo, we're done.